So here we are again, my ambassadors of mathematics, and we're on another journey. And when I look at your faces, I see prospective doctors. And you know you can't get there without mathematics, irrespective of which field you pursue. Now today, we want to move on to another concept. A concept in mathematics that you can use in your lives after you leave my classroom. So let us see what we are about to learn. We want to look at a topic called statistics. And in statistics, we want to look at another topic or another concept which is referred to as the mean. Now before we get down to the mean, we should understand what statistics is. Get a general idea as to what statistics is. Now when you hear the word statistics, it generally refers to collecting, analyzing, interpreting, and presenting something called data or information. What kind of information can we interpret, analyze, present, collect? For example, we're really bothered about the number of accidents we're having on our roads. So we visit the police stations where these reports are made after we have our vehicular accidents. From the reports, we can tell if any person died, the kind of injuries that we have, the kind of motor vehicle that was involved in the accident. From that information collected, we can have charts. And then we can look at which division, whether it's subdivision A, B, C, D, or E, we're having the most deaths. Or we can say West Coast of Demerara has the most dangerous roads in Guyana. Statistics helps us to understand that. Now let us see what the mean is all about. Now in this lesson we have the mean as our focus. And we want to use, or we want to find the mean or calculate the mean through two differing ways. One is from just having a set of numbers, and two is by making use of something called the frequency table. So we'll take them one by one. Before we go on to actually finding a value of a mean, here we have some key points. Statistical information is called data, as I told you before. And then we have a little sentence there that says the mean, the median, and the mode are statistical averages. These are three concepts in statistics that help us to analyze and understand the kind of information that we collect. It gives us a better picture or a representation. Further, the mean is a value that helps us to summarize an entire set of numbers. So let's delve into the mean. So there are three types of averages that we use in our average day as we move from day to day. And again, they're the mean, the median, or the mode, or the mean, the mode, and the median, the three M's. Of the three, the most frequently used is the mean. The most, even when you're learning mathematics, not only in statistics will you encounter the mean, but other areas, other subtopics in mathematics. Maybe you're in algebra or you're in sets. You will find the mean. You might not find the mode and the median coming that frequently. So the mean, or even sometimes you're in the market, you look at the average price of maybe Bora or a pound of beef, or so the mean is the more popular of the three. The mean is a value that helps us to summarize an entire set of numbers. Now sometimes there is need to find or use a single value which represents or characterizes the group as a whole. So I have a set of third form students and I want to label them by age. So I know that there's a possibility I would find 13-year-olds, some are 14-year-olds, and some 15-year-olds. But I don't want 3 different age. I want 1. So I can say in the third form, I can find a set of 14-year-olds. So that 1 age group characterizes this set of group of students. But that doesn't mean that you wouldn't find any 15 or 13 or 12-year-old. Just this 1 number we use to represent a group. Another example, let us say we go to the market and we see a truck coming into the market and it is loaded with vegetables it had brought from outlying regions. And we see about 25 baskets of tomatoes. And we want to know on average, how many tomatoes are there per basket? We can use the mean to represent, we can say maybe an average 100 tomatoes in each basket. But some baskets might have 98, some might have 101. But a mean tells us something about all the baskets. Now, I've been telling you a whole lot about the mean and how the mean can be used. I need 2 persons to tell me how they think the mean can be used.
It's like averaging the population of the school.
The population of the school. So if we want to take a number of schools and then we want to label them as whether they're A grade or B grade or so on, we can say A grade schools have roughly 575 students. So we know that every school that is graded A in terms of population, you know that the school should have somewhere about there. That sets a limit. Or we talk about these schools. These schools, maybe they have about 200. So you can see a distinction between the different schools. Another example.
Let's say you're trying to find the average performance of the class.
Exactly. Beautiful. The average performance of the class. So we can come up with a performance and say the average of 4 science is
84%.
oh, beautiful. Beautiful, Evander. 84%. So I know definitely that those students are likely that when the CXC results is published, we're having all distinctions. But we'll see later on how the mean can be affected. In as much as Evander says 84%, we can have somebody in that very class having a 25%. Thank you very much, Evander and Ayana. Now, after discussing all of that about the mean, let us get down to how we can actually use numbers to find the mean, get into this mean thing. So we're given a set of numbers, 2, 3, 6, and 10. And we want to find the mean. We want to find the average. We want to find the arithmetic mean. So what are we going to do with the 4 numbers? We're going to sum them. So if you look here, you see we're summing them, 2, 3, 6, and 10. And then we notice that under the vinculum is a 4. Our denominator is a 4. Why was a 4 being used? Or why is a 4 being used?
Numbers added.
Because they are, the amount of elements there is 4. So we sum and then we divide by how many of them there are. So when we sum there, how much are we going to get? 21. So let's check it out. So we have 10 and 9, 19 and 2, 21. And we divide 21 by 4. And anybody want to give it a shot what the mean is going to be?
5 1/4.
5 1/4.
Sorry.
And 5 1/4 as a mixed number with decimal would be
21. As a
5.25.
Excellent. Brilliant. I know you're going to make it. So, we're predicting that our answer is going to be 5.25, as Yannick said, or 5.25. 5.25. Now let's see if that is so. But first, the mean is defined as the sum of the set of numbers divided by the number of values making up the set. Sum for the number of values making up the set. Now, previously you saw that we took the numbers and we summed them, and then we divided by the number of values they are. Now, here we have a standard symbolic representation where we have symbols put in the form of an equation to help us find the mean when we're just given a couple of numbers. X with a bar on it takes the place of the word mean. Here we have an X there, and this symbol here means to sum up all of whatever it relates to. In this case here, we're summing all the X's. Our X's were 2, 3, 6, and 10. The score or the value of the observations. We had 4 observations and then we summed them. Also, after we identified what the X is, we sum there. And then last of all, our N represents the frequency, the total frequency. That means how many of them they were. Now let's get down to our value now. A batsman scored, after 8 innings, we had 5, 11. What are the others?
30, 32, 9, 41, 17, 23.
Okay. So we have 8 numbers which represent 8 scores obtained by the batsman. Now we had a previous example where we went ahead and we calculated the mean. Now I want you to take these scores and tell me the average score of the batsman over those 8 innings. Stefan, what was your answer?
21.
21. So Stefan is saying that his mean is 21. Now Stefan, you're going to have to take me through the procedure into getting 21. What did you do, Stefan?
Add the 8.
What did you do?
Add 8 different scores given.
And what are the 8 different scores?
5,
5,
11,
30,
32,
32, 9.
9, 41, 17, and 23.
Okay, and when you sum them, what you got?
163.
160.
68, 168.
8. And then what did you do after that?
Divide 168 by 8.
Divided by 8. And what's the quotient when you finish? You had?
21.
21. Okay, so Stefan has 21 as his mean. Now let us see if what Stefan is saying, or the answer that Stefan has, is correct. So we want to find the mean score of this cricketer. Let's see our solution. So there we have the scores being summed. And the sum matches what Stefan has and what the entire class has, which is 168. Then 168 is divided by 8. And what do you notice the outcome is? 21. Again, let us use the equation that is given to see if we end up with the same 21. So the mean is the sum of all the x's, and the sum of all the x's 168, and the number of elements or the number of scores that they are would be 8. So here we have substituted the values instead of using the symbols there again. And when we did our division, the quotient worked out to be 21. Very good, very good. Yes, very good, wonderful. Now, the first way in which we could have calculated the mean are we're given some numbers, and we just simply sum them and divide by how many of them there are, and we come up with that one number. So we could have said in that example that that batsman scored an average of 21 runs per inning. But then there are times when we have tons of information, and time will not permit us to sit and just go through them. So we have to find strategies in which, in a very short space of time, we can come up with our answers. So now we move to the frequency table. The frequency table is a strategy that helps us to compile a large amount of information and then find or get our results in a very relatively short space of time. So as we were saying, that the frequency table helps us to calculate the mean. Or before we get the mean, we would have had tons of information, and we want to get this mean in a relatively short space of time. So we make use of the frequency table. So here we have another statement saying that the mean can be computed via the use of a frequency table. Now let's explore example 2. We have a set of farmers who have an orchard with oranges, and they collect these oranges on a daily basis. Now let's look at some information. Can we sit and punch and have all of those in a short space of time?
No.
Yes.
No, it's going to take a very long time. So what we're going to do is make use of concepts like tally and frequency and so on to get our mean. So we can see that a number of farmers collected 100 orange per day. Some collected 200, some collected 300, and so on. And the most collected per day by 4 farmers was 500. Now our aim here is to find the daily collection. But the daily collection that we want must be a figure that represents all the farmers. So we want to find the mean. So here we have our frequency table. So what we did, we took the information that we had and we summarized it. We have 10 farmers collecting 100 oranges per day. Then we ended up with 4 farmers collecting 500. Now what I want you to tell me is how were these figures calculated?
I take the collection of oranges and times them by the frequency.
So we took the collection of oranges, for example 100, and we multiplied by the frequency. These are the number of oranges collected per day, and these are the amount of farmers collecting this amount per day. So we have 10 by 100 gives us 1,000. Or we have 400 per day, and that was done by 9 farmers, and 4 nines are 36, or 400 by 9 would give us 3,600. How many farmers were there in this situation?
50.
50. We summed the frequency and we got our 50. And how many oranges were collected?
30,500.
That's a lot of oranges. We can open an orange juice factory. Good. Now, how can we take information off of this frequency table to find our mean? Or what specifically will we use to find our mean? Which values?
collection of oranges, the frequency, and the answer.
I want to know, we took our information, summarized it, and we have it displayed on a frequency table. What I want to know, after we finish here and we have information presented to us, 50 farmers collected 13,500 oranges over that day. But we want one figure to tell us an average of how many oranges were collected per day. So which figures are we going to take off the frequency table to calculate the mean?
Yeah.
Which ones are we going to use?
13,500 and the 50.
Excellent. We're going to use the 13,500 and the 50. Let's just see if that is so. So here we have an explanation of how we got some of the data on the table. The table shows 10 farmers collecting 100 oranges, 12 farmers collecting 200 oranges, and so on. So if 10 farmers collected 100 oranges, we know definitely it's got to be 1,000 oranges collected between those 10. And the same thing with the 12 farmers. 12 collected 200, so that would be 2,400. So there we have it. The total number of oranges, as Yannick said, over the number of farmers. 13,500 divided by 50. And we say an average of 270 oranges was collected by those 50 farmers every day. So you see how we can use the mean to generalize. For example, you're doing an agri-science assignment or an SBA, and you went to the farm and you saw 15 chicken pens with chickens in them, and you can say an average of 35 chickens were in a pen. So we're using the mean there again to make an estimate. Let's continue. So the mean daily collection was 270. Now let's look at example 3. The mean amount spent in traveling to work by 6 women is $80. Now you must note that this $8 is one figure that represents 6 different women. Then we have 4 other women having $100 represent them. So let's take note of that. What is the question? What was the mean amount for 10 women? So we have 6 women. So we have 6 women, and this one figure of $80 represents them. And then we have 4 women, and this one figure of $100 represents them. Now we want to put all of them together, say 10 women, and we need a mean for those 10 women. Will it be the same as 80 or 100, or will it be different?
It will be
different.
It will be different. So let's find out how it will be different, or why it will be different. Now I'm going to give you a hint. Yes, a hint. The first 6 women would have paid $480. So an average of $80 per woman. Okay? What is the amount the 4 women would have paid?
$400.
How did you get that, Yannick?
The times 100.
Man, you are quick. You are fast. You were like zoop. So Yannick said for the 4 women, he would multiply 100 by 4, and that would give us $400. So let's see if Yannick is anywhere close. Is he there?
Yes.
Right on target. Beautiful. Now if the 6 women paid $480 altogether, and the 4 women paid $400 altogether, together the 6 and 4, 10 women paid how much?
80.
$880.
$880.
$880. Yes, Yannick, $880. So if 10 women paid $880, an average of how much was paid per woman?
$88.
How did you get 88, Gabrielle?
880 divided by 10.
880 divided by 10. And when you're dividing by numbers like 10, 100, and so on, you have 1 0 here. We move the decimal point one place forward. So we have 88 representing the 10 women. Very good. Very good. So the mean amount is $88. Everybody like the mean?
Yes, miss.
Good. So you can use the mean when you leave my classroom. Let us see what else is there. Example 4 says we're given an amount of numbers. There we have them: 1, 3, 7, 9, 2, 10, 8, and 4. And since we're on mean, I know that question is asking us to find the mean. Good. Now we have 4 responses. This question here was taken from a national grade 9 exam. And the 4 responses are A, 4.4, B, 4.5, C, 5.5, and D, 9. Now before I reveal the key to you, I want you to tell me what the answer will be.
C, 5.5.
Very good, Stefan. Very good. Stefan says 5.5, but I want the others to go through the process and make sure that it is Stefan is correct. He's like the hummingbird. Zoop, zoop, zoop. You got that, Alicia? Got that, Diana? Ivan, you got that?
Yes, miss.
Yes,
Very good. Now let's see what the key is. So those students who took that exam in 2005, if they had circled or shaded C, they would have got it correct because we have the key as C. Now there we were looking at the mean, and in a very short space of time, if we just have a couple of numbers, we can say the mean is found by just summing them, dividing by how many of numbers they are, or if we have a set, the amount, and the quotient is that one value that tells me something or represents a group of values or a group of numbers. On the other hand, we discovered that a frequency table is also very helpful. We also use the frequency table, or we found out that the frequency table was also a useful strategy of finding the mean in a short space of time. Now let us summarize what we learned in this lesson. What is the mean defined as?
Mean is defined as the sum of the set of numbers divided by the number of values making up the set.
Very good, Stefan. At least I know you can read and you understand what you read, didn't you?
Yes, miss.
Okay, let us keep on summarizing. There we have our equation, which helps us, or which aids us in arriving at the mean of a set of information. Further, Daryl, would you want to read that for me?
No problem. The mean is the most widely used type of average. Its value helps us to summarize an entire set of numbers.
Exactly. It helps us to give life to a set of numbers. That one thing we're dealing with instead of all the others. So there we have all the information we can about the mean and all the information we need at this stage of our lives in mathematics about the mean. Now I need to give you some guidance in what you did as reinforcement in the last lesson. So let us see what you did. You had to go to the book Mathematics for Secondary Schools in Guyana, book 3. It's locally published, And we went to page 97 and we looked at exercise 8B. Question 2 was selected and the information said we're given a mapping diagram and a set of x's and a set of f of x's. Now what was the instruction? It says use functional notation to state the rule. Now we had our x's 2, 4, 6, 8 and 10. And then after using our rule or after some operation, we produce 8, 14, 20, 26 and 32. What did we do to the x's to end up with the f of x's? 2 is mapped to 8. 4 is mapped to 14. 6, 20. 8 to 26 and 10 to 32. And whatever we do to the first, we have to do the identical thing to all the others. So whatever we do to 2, we have to do to 2, to 4, 6, 8 and 10. What did we do to them to get the outcome that we have there? Yes, students. So what do we do to the set of x's to get to the set of f of x's or the set of y's? Here we have our set of y's. What do we do?
You take each number in x, times it by 3 and add 2.
We take each number in this loop and we multiply them by 3 and then we add a 2. So let's come up with an algebraic expression. So we take each x, multiply it by 3 and then we add a 2. Now let us see if Yannick is correct. Let us take 6 for example. 6 is the x and we're multiplying by 3 and then we add our 2. 6 3s are
18.
and if we add 2 to 18 we're going to have
20.
Let's see if we have the same thing. Back to our 20. But if it works for 6, it must also work for 10. Try it with 10 for me and see if we're going to have 32. See if 10 is going to give us 32. Got 32, Stefan?
Yes,
Delicia?
Yes.
Gabriel?
Yes.
Very good. What about 2? Let's try 2. Hey, Darrell?
Yes.
Yes, very good. Darrell didn't need to write. Darrell got it. Very good. Very good. Very good. So the rule or the functional notation that we had to derive was 3x plus 2. Very good to all of you who got it. Very good. And keep on working the other questions so you can have more reinforcement. And just as how you love the mean, you can love relations, functions, and graphs. Now for today's lesson on the mean, you're going to go to page 105. Page 105, exercise 9A, and you're going to look at question 10. And we're using the same textbook. I think our authors have done a fabulous job. Very, very good job. So I expect you to go there. And not only because they say work question 10. All the questions in that exercise, attempt them. It's very good for you. It will make you a better mathematics student. Now in this lesson, we were looking at the mean. And we know how we can use the mean in mathematics. But on the other hand, we also know that the mean has another meaning. So I don't want you to be mean. I want you to go out there and liberally tell people about the mean as it relates to mathematics.